Hi, everyone. Welcome to today's session. In today's session, we will discuss the user's perspective, the differences between the APL64 file system and APL+Win file system, and review the recent improvements made to the APL64 file operation. One of our design goals for APL64 file system was to make migration from APL+Win as smooth as possible. Given that APL64, including its file system, was developed using a more modern general-purpose and object-oriented programming language, some minor differences may exist between the two file systems. Our development team is working closely with our users to address any potential issues and continue to improve the implementation. We wanted to thank many of our users for trying the file systems during the earlier releases of the system and providing us with crucial bug reports, which enabled us to make necessary fixes. Currently, all APL+Win file functions have been ported to APL64. Besides resolving issues reported by our users, our development team is still working on addressing design issues related to storing strings and 16-bit characters in files, as well as handling the case sensitivity issues of file passes. One of our users asked whether we can add an optional open mode argument to the qua-cf type function, similar to the qua-accent type function. The open mode argument enables the file owner to grant specific file access permissions to other users or processes. For example, the owner of the file can have read and write permission, but only grant read permissions to others, or specify read-only permission for the owner and others. While we were considering the request, we realized that we could optimize the performance of some of the colossal file operations depending on the open mode. For example, when a file is exclusively tied or shared the read-only permission with others, the file is not expected to be modified by others. Thus, doesn't require reloading the file header or reloading the file directory or the host table of the tied file for every file operation. In our internal testing, the results show that reducing the access overhead improves the performance of some colossal file operations. The degrees of the improvement vary based on several factors, including the file open mode, the complexity of the component, and machine configuration. Generally, we can expect some performance improvements when the file is exclusively tied or shared read-only assets. The syntax of qua-cf type is similar to the qua-accent type. The open mode argument is optional. When open mode is not specified, the behavior of the qua-cf type is identical to that of APL+Win. The supported open mode includes 0, 2, 16, 18, 32, 34, 64, and 66. Unlike qua-accent type, the APL64 doesn't support write-only mode because colossal component file operations generally require reading the file. The value of the open mode is the sum of the access permissions for the file owner, and the access permission granted to others. For example, if we specify mode 34, which means the owner of the file has the read and write permission, but others have the read permission. When others needs to access the same file, they must specify mode 64, which grants a read permission to themselves and allows the owner of the file to have a read and write permission. Here's a simple test we did. The test function measures the total time required to read all the components from a colossal component file. It first creates a file and then add 10,000 floating point matrices to the file. After that, it ties the file and read all the components. The APL+Win result is on the left. The APL64 session contains results using different open modes, or without specifying the open mode. We observed that the performance of the quad-CF read improved compared to the APL+Win when the file was exclusively tied or shared read-only access with others. The second improvement also came from a user's suggestion. The APL+Win quad-CF RDCI function can only return information about one component each time. The improved quad-CF RDCI function can now accept an integer component number or a component vector. The optional left argument provides flexibility in choosing which of the 10 elements of the result vector to return. For example, if we need to obtain information on 10 components at once, we could use the for loop to get a result, or use the improved quad-CF RDCI function to achieve the same goal. The new quad-CF RDCI function also reduces file access overhead. It only needs to lock or unlock a file once if it's shared, and read the file header and the file directory once to obtain the information of all the specified components. Here's another example of using the improved quad-CF RDCI function. In APL+Win, a program can obtain file handle using the get.handle function provided by the utility workspace. Some users use the file handle to lock or unlock a file. Some users use the file handle to flush file buffers. Some users use the file handle to obtain file timestamps. And some users use the file handle to get other file information. This APL64 was developed using a more modern programming language that employs high-level abstraction such as file streams rather than direct file handles to simplify the file operations and enhance safety. APL64 cannot directly return a numeric file handle. Understanding the needs of our users, we developed 6 new file functions, namely quad-nlock, quad-nflush, quad-flock, quad-flush, quad-cflock, and quad-cflush. The quad-nlock, quad-flock, and quad-cflock can be used to lock or unlock a native file, a component file, or a colossal component file, respectively. The arguments to these functions allow programmers to specify the offset and the length of the range to be locked or unlocked. The quad-nflush, quad-flush, and quad-cflush allow programmers to clear file streams buffers and write any buffered data to the file. If a program needs to obtain file timestamps, it can use the quad-nfv get creation time, get last access time, and get last write time methods. For detailed information on these new functions, please refer to the System Functions Manual. As a result of the change, APL64 quad-CF info no longer returns a valid file handle. Instead, it returns a 0 for the file handle. Another change in the file system is the use of the UTC instead of local time to store timestamp. The APL64 F-Live, Live, and with Live now supports wildcard arguments. Here are some examples of using the wildcard arguments in these functions here. I'm gonna exit out of here. We're gonna try a couple examples. This is my test folder. I'm gonna execute the flib first. So it's gonna list all the component files in the folder. And if we want to narrow the listing of the files, for example, say any file, any component files beginning with any characters, 2 characters, and a substring TEST, and followed by any other characters. So it will give us those results. And if we run the system command version of F-Live, that's the one before. And if we want to search any component files containing the substring 1 file, for example, like this, it should give us the result here. And now let's try the live function. This should list all the files and subdirectories in the folder. If we are only interested in a text file, for example, it should give us the result here. And if we execute the system command version of the live, and for example, beginning with any letters, and then followed by letter B, and then 2 more characters, and with any extension, for example. That should give us the result here. And let's try the with live. The with live, by default, will return only the .w64 workspaces. If we want to return the .w3 workspace, we can do something like this. By the system version, system command of the with live, which should give us the same result before. And if we say we want all the workspace begin with the word copy, for example, that should give us all the expected result here. All right, so that's the change to the F-Live, Live, and with Live. This folder. And another difference between the APL64 and APL+Win file system is the host error message. Because APL64 and APL+Win were developed using different programming languages, APL64 may generate different host error messages than those generated by APL+Win. If a program developed in APL+Win tracks a specific host error message without making any changes, the error handling logic may not work correctly in APL64. We create a utility to map commonly found APL64 host errors to the corresponding APL+Win host errors. Currently, the host error map consists of the system default host error map and a user-defined host error map. Our developer team maintains the system default host error map. Users can add or remove entries in the user-defined host error map. The host error maps only need to be set up during the program development. At runtime, when the system encounters a host error, it searches the host error map and substitutes the error message if a match is found. Show a couple of examples here. APL+Win. Folder. Let's say if we want to create, let's say if we want to type the file and it doesn't exist. So this is the host error message we get in APL64. And if we try the same expression, APL+Win, and we get this error message, even though the meaning of the message is almost identical, but the exact wording is a little bit different. So in order to, if your application checks the specific text of the error message, the logic may not work correctly or properly in APL64. So to avoid this problem, we can use this utility here. And I previously disabled some of those mappings just for the demo purpose. So I'm going to reactivate this. And let's say we click OK. And if we execute the same expression again, now you can see the host error message is identical between the two systems here. Now let's try another quick example. So this time we're going to type another file. And in this case, I previously modified the file, the asset permission, so we should get the asset denied error message. So it's denied access to the path is denied. So if we try the same example here, and you can see the error message is slightly different. It just says access is denied without a path, like in APL64. So again, once we can go to here, use this utility. I'm gonna enable this mapping here. And now if we execute the same expression, we should get the same identical error message. All right, so let me try one more. This time I'm gonna do the it says file already exists. Slightly different error message. The file exists without mentioning the file name in the past. So if we come here and activate this one, we execute this, you will see that the file is this identical error message here between the two systems. Now let's try the example of using the user-defined error message, host error message. And here we're going to do access the network drive. File for you to figure out the network path was not found. And if we do this here, so similar messages, but not exactly the same. This network path was not found. And the numbers here, the integer numbers, the first one is the same and the third one is different. and the second one is different as well. And then to show how we can use the user-defined host error map here, we can click on this button. I don't have any here, so we can click on that. And then the first field is automatically checked. You can disable it at any time you want. And the H result is the third integer on the APL64 output here. It's a large negative number. I could copy it. And the host error is the first integer number here. It's just actually on both systems there have the same host error numbers. So it's 1005. The reason we need those two fields is to correctly identify the error that we wanted to map. So with those two fields, we can be certain that the error that we wanted to map is the error that we are searching for. So, and then the last field, the host message, is the one that we want to copy from APL+Win. We want the entire error message here. So I'm going to copy this. Now we say to click the OK button. And now let's click on the same expression here again. So you can see now we're having the same error, host error on both systems here. So this is how we use the user-defined host error mapping. So all right, I'm gonna. I guess that's pretty much all I wanted to share with everybody here today. Presentation here. So so we are. If you have any questions or comments, please feel free to ask and provide your comments on this.